All right. Hello, good morning, good afternoon. Thank you so much, ladies and gentlemen, for attending today's webinar. Please let me know if you can hear my voice and if the video feed is okay, so that we can get started. All right. So in today's webinar, of course, I'm going to cover the DMAIC methodology on Lean Six Sigma. So just to give you an overview of what exactly are we going to do and, the mode of this CPD program. So when it comes to Six Sigma, okay, the most important thing to do, I think, is basically to record your activities, okay, because your Six Sigma project, that means like after you identify and basically improve a process, okay, when you identify and address any deficiencies in a process, you have to record it so that, this becomes your organizational knowledge and also as for training material, basically to document your quality management journey. So that is going to be the main focus of today's webinar. In today's webinar, I'm going to be focusing on giving you the skill basically to record and report the the improvement activities that you do when you use Lean Six Sigma, because that is the most important part in Lean Six Sigma. So this is going to be the case study. I'm going to be using two case studies in this webinar so that I can explain and walk you through. So this is a case study which is going to be relevant for people who have got services in the organization. And this is going to be a case study for people who have got products in their organization. So these two case studies, I'm going to be using them basically to support what we'll be covering or the information that is in the PowerPoint presentation. In today's webinar, the delivery is going to be very simple. I'm going to walk you through the 5 stages: the define, measure, analyze, improve, and control. And what I'm going to do at each stage, I'm going to show you what are you expected to do, okay? And then I'm going to show you how to do it right here. And then I'll go to the case study, and then I'll show you how it was done. And then we come back, and then I'm going to show you also how you can get started in your organization. You see? And then when we go to the measurement phase, again, I'm going to do the same thing. I'm going to show you exactly what you need to do. Okay. And this next slide is going to cover how to do it. And then we go to the case study, and then I'll show you how it was actually done. And then we come back right here, and I'll give you a checklist on how to get started. So that is going to be the delivery mode for all the 5 stages. In that way now, you are actually going to see not only what needs to be done, but how to do it, and also the other examples that I'm going to be giving you in the case studies. As I'm going to be explaining through also, this is another case study from Starbucks. Okay, they use Six Sigma to improve processes in the organization. So I'm also going to be explaining how Lean Six Sigma is being used at Starbucks and so on like that. So that is basically the overview, and also that is what you're going to get in today's webinar. So by the end of this training, or the end of this webinar, I'm going to give you resources and basically explanations to basically help you record and report a CPD program like this. Okay, this is a report that you do at the end of your Lean Six Sigma project, and then of course you can come over here and you can record it on your CPD profile, right? So that being said, let us actually get started right here. So once again, thank you so much, ladies and gentlemen, for taking time out of your busy schedule to join us again for the Lean Six Sigma training program. My name is Farai Langton Chuai. I'm a risk management consultant here at the QHSC Group. We are based in Dubai, Silicon Oasis in the United Arab Emirates. So what I'm going to do, we are now going to start off by really just explaining the definition, okay, of what exactly are we trying to do here, and how exactly can you use Lean Six Sigma. So today's training now, I'm going to show you this training, or what you're going to do in the next 90 minutes is going to focus on identifying and addressing inefficiencies in a process. Okay, this is going to be the main key theme of today's training. And let me actually show you that this is to identify and also to address any efficiencies in a process. What you're trying to say here is that, when you're using Lean Six Sigma, okay, why do you need it and what exactly are you doing? So when we say you need to identify Lean Six Sigma, or the DMAIC methodology is used to identify and address inefficiencies. What exactly do these inefficiencies look like? And basically, what do these processes look like? I think that is a good starting point that is really going to set a platform for me to explain further. So I'm going to start by showing you a simple example of an inefficiency. So coming back to this case study right here, you can see that, in every organization, including yours, or if you look at any process flow, if you look at any product or service selection process, okay, there are basically stages. These can be steps from the time when a customer requests for something until delivery, right? So as the customer is going through, or as you are preparing the product, or as you are delivering the service, you can see that at some instances, there may be stages or points when the customer is not satisfied, where you fail to meet the needs and expectations of your clients or the requirements of the product or the service. So basically, this is an example of the inefficiencies in a process. Okay, as you can see right here, again, just about the payment stage, the customer is not satisfied because the payment is taking too long. So this is now how you use Lean Six Sigma. The idea behind Lean Six Sigma, the DMAIC process, is for you to identify a process, to identify the customer journey, is for you to basically identify, the process flow in your organization, and then these dips now, when these instances or the stages when the customer basically is not satisfied, that is what we'd like to do to improve so that we stay above this dotted line. So this is an example from Starbucks or a coffee shop, but it can also be used right here in the organization. As you can see, this is DMAIC Process Six Sigma being applied for the reduction of defects in rubber gloves manufacturing processes. And then right here, Lean Six Sigma is being used to reduce the time it takes to give out credit card and loans in a bank. So that is exactly the theme that you're going to be doing today. I'm not only going to let you know only these three examples, but I'm going to show you how you can identify and address inefficiencies in any process. As you know, you're also going to receive these 15 case studies from 15 different industries in Six Sigma. The whole idea in all of these case studies that you are going to receive from government, construction, e-commerce, manufacturing, warehouse, what you have it, okay? Healthcare, distribution, all of these Six Sigma from different case studies, from different industries, that is basically showing you how Six Sigma was used to identify and address inefficiencies in all of these industries. So again, these case studies, they are going to come alongside your certificate, and you can use them to see how Six Sigma was used to do that. It's very important for you to really understand what exactly do I need Six Sigma for and why do I need it. And today I'm going to show you that, how you can use it to identify and address inefficiencies in your product or service realization processes. With that being said, we now have to look at the methodology itself. Like, okay, how exactly can I identify and address inefficiencies in a process? How can I improve outcome and to make improvements predictable? Well, you basically have to do 5 things. You have to define the problem, you quantify the problem, you identify the cause of the problem, you implement and you verify the solution, and you maintain that solution. This is called the DMAIC methodology. And ladies and gentlemen, this is what you use to identify and address any inefficiencies in a process. And one thing that I also like to say before we proceed is that, in Six Sigma, it does not have much to do with the industry or the product or the service or the scope of your activities, okay? It has got basically all to do with the process. So you're going to see that the same way that you're going to identify and address inefficiencies at this Starbucks location in this coffee shop, it is probably the same way that inefficiencies were identified and were solved in this project from Nike. Okay, and then you're also going to see that that was going to be the same way, they identified and addressed inefficiencies at Amazon right here, at eBay. You are going to see that that is the same way they identified and addressed inefficiencies in the government in Houston, Texas, in the United States. That is the way that you're going to see it was done the same way right here in the human resources, in hospitality. So in today's webinar, what you're going to focus on is exactly like, whatever process, whatever industry, whatever scope, whatever context that you're going to be presented with, I'm going to give you a simple methodology to follow so that you can identify and address any inefficiencies so that you can work either it's a process in a bank or whether it's a process in a rubber manufacturing gloves or whether it's a process in what? In hospitality, a process in customer service, a process in engineering, it does not matter because you know the proper technique to identify and address those inefficiencies. That is the most important part for you to know in Lean Six Sigma. So with that being said now, how exactly does this DMAIC methodology work? For you to use Six Sigma in any context, in any process, in any condition, is for you to understand the underlying concept. Like, okay, when we say define a problem, what exactly does it mean? When we quantify the problem, when we are doing measuring, analyzing, improving, and controlling, you should not only use this in one scenario or one process, but basically in any condition under whatever circumstances. So the idea in it, when you look at the fundamentals of Lean Six Sigma, when you look at the basic concepts, okay, the DMAIC methodology is designed to structure these following questions. These following questions, as I've told you, ladies and gentlemen, these are the same questions that we address from the case studies in eBay, in Amazon, in Starbucks, in the bank, in rubber manufacturing, in construction, in hospitality, and so on. When you break it down, it all boils down to these questions. So what you're going to do, okay, you're going to identify any product or service selection processes. You are going to identify your process flows. You are going to identify any customer journey. And then this is exactly what you're going to do at the end of the day. It's very important when you're using a technique, it's very important for you to understand the fundamentals and basically the foundation. Because if you understand the foundation, as you are looking at right now on the screen, okay, this is going to allow you to use Lean Six Sigma, i.e., this is going to allow you to identify and address any inefficiencies in any context, in any industry, in whatever situation. So whenever you see Lean Six Sigma being used, and including those 15 case studies from 15 different industries, you are going to see that at the end of the day, this technique, the Lean Six Sigma, the DMAIC methodology, it's used to address what does the customer define as the problem, what are the characteristics of that problem, what are the root causes, and what controls should be implemented to sustain this improvement. So whatever that you're going to do today, including the case that I'm going to read out to you, this is all the questions that we need to answer. Just to address and also to give you further examples here, okay? We said this DMAIC methodology is used to identify and address inefficiencies in a process. So let's say, for example, we have a process at a coffee shop. This is basically a process of what? Of people coming on and ordering a cup of coffee and then drinking them, right? This is a service selection process at Starbucks or at any coffee shop, really. Okay, so at this point now, we are going to determine what does the customer define as the problem here. And then you're going to see that the customer defines as the problem because the place is crowded, okay? And then also the payment application sometimes declines. In this scenario, the customer here basically describes it as a problem because there's no sitting area, and also here the payment application is not working. So basically, this is the first question that we are going to address here. And then we are going to look at what exactly are the characteristics of that problem. So these characteristics of these problems now are basically this one that you see right here. Realize the application constantly logs out. Okay, the application is difficult to open and so on like that. So we characterize those problems. And then we now determine what are the root causes. Why is it happening at that time? And what controls should be implemented to sustain an improvement? What controls should be implemented so that we don't go down this dotted line, we always stay above this line. And this same methodology, these same questions, this is what you're going to see when you read out this Six Sigma project. This case study, the first one is from Nike. This is what they use on their swoosh logo. We have got other case studies from the retail industry, from the field service, from information technology. All these industries, they are using Lean Six Sigma, food service, manufacturing, and so on. And when you go throughout all these case studies right here, you are going to see that at the end of the day, these are the questions that need to be addressed. So that is exactly what we are going to do today. And that is how you identify and address inefficiencies in a process. Now, so just to give a recap here, what are we trying to do? We are trying to identify and address inefficiencies in a process. How do you identify and address inefficiencies in a process? At the end of the day, these are the questions that you'd like to answer. Now, before we now get started, we need basically a measurement unit, because you cannot improve what you cannot measure and you cannot manage what you cannot measure, right? So this is called a Z chart or a sigma level, okay? This is where the name Six Sigma comes from. So at this point now, all of us now we understand that, okay, the main objective, what we are trying to do here is to identify and address inefficiencies in a process, right? So we need a measurement unit so that we can see, before we have identified and addressed inefficiencies, what was the performance or the capacity, and also after we have identified and addressed these inefficiencies, what is the improvement. So we need a Z table like this. So what exactly does this Z table mean? Well, what it means is that, let's say we are at sigma level 1. What does sigma level 1 mean? For example, let's say right here, sigma level 1, okay, it means that if a process is being repeated here, how many defects, okay, or inefficiencies or mistakes basically that are going to happen right then. So for example, let's say this process right here, the first one, these customers right here, they're experiencing level 1, sigma level 1. It means that these dips that you see right here, okay, when the customer is not satisfied right here, this is happening 690,000 times. It means that only 30.85% of the customers, they are satisfied, okay? And then giving you again another example, let's say this process right here is at sigma level 3. What does this mean? It means that, this process, if it is repeated 1,000,000 times, okay, how many times are we going to have instances when a mistake is going to happen, when the customer is not going to satisfy? If 1,000,000 people are going to come to this Starbucks location with a sigma level 3, what is going to happen? It means that 66,800 mistakes or 66,800 dips right here, they are going to happen per every 1,000,000 people who are going to attend. You understand? So, and then if it is sigma level 5, okay, let's say this one right here, sigma level 5, it means that if we are going to save 1,000,000 people, for every 1,000,000 people who come to this Starbucks location, these dips behind this dotted line, this is going to happen 230 times. Okay, so how do we use this sigma chart and this table? Well, it comes back to the main thing that you're trying to do here. We are here to identify and address these inefficiencies. So these inefficiencies, ladies and gentlemen, they are the ones that are represented as defects. So what you're trying to do is to identify and address these defects so that we can improve. So the whole idea and what you're trying to do here is basically to answer all these questions right here, to address these questions so that we can move from sigma level 1 to sigma level 3, okay? Because that is what happens when you identify what exactly is causing those 690,000 mistakes. We are going to identify when and how, okay, those defects are happening, and then how can we improve them so that we go to sigma level 3, sigma level 5, and then hopefully up to 6 sigma. That is basically all what we are doing. And then I'm going to show you how to do it in 5 simple steps. I'm going to start from define, measure, analyze, improve, and control, so that you know how you can identify and address these inefficiencies in any context, in any way. So at this point now, what you're going to do, I'm now going to go back and then we are going to start with the define stage. Okay, at this point now, this is the first step that we do so that we can identify and address these inefficiencies in a process. So we are going to define the problem. Now, as I said at the beginning of the webinar, you are going to see that the way, or at a fundamental level, define, measure, analyze, improve, and control, it is the same thing, okay, that usually happens in all of these case studies. No matter where you go, when you look at a Six Sigma project that has been correctly done, okay, this is what you're going to see. So I'm going to use that information, okay, basically to help you understand that, okay, at a defined phase, what exactly happens at a defined phase? And you are going to use this now in two ways. Number one, you are going to know what to do when you are defining a problem. And also, the other way that you can use it, like if you have got any Six Sigma project, when you open that case study, what do you expect to see? Okay, probably some of you maybe have never worked in manufacturing or anything. But if someone is going to ask you, can you please check if our Six Sigma project has been done correctly? You have an upper hand because you already know what are the features and the characteristics. What do I have to see when it is done correctly? So that is where I'm going to start from. After that, I'm going to introduce you to the different tools that you can use to achieve these intended outcomes. Okay. And then after that, now I'm going to show you how it was done. And then after that, I'm going to show you how you can get started in your own organization. Right. So with that being said, let us now get started with the first step of identifying and addressing inefficiencies in a process. So when it comes to Six Sigma, this is probably the most critical part. If you see people basically who struggle with Six Sigma, or when Six Sigma is not being efficient, or if it's basically not working, the usually most of the times is just not knowing what to do at a particular stage. Okay, and if you don't know what do you need to do at a defined phase, definitely the chance of success, they are going to be slim. So it's very important for you to know pre-hand before you do anything. Let's say if I'm going to request you, can you please come to identify and address inefficiencies in our process of so and so? You should actually know beforehand, before you even come to our enterprise, you should actually understand what do I need to do. So with that being said, in the define phase, you will have to define the problem. What does it mean to define the problem? Well, this phase now is concerned with identifying the problem. You define the requirements. What do we need to solve this problem, and what it should look like if it is done correctly? Going back to the questions now, in the define phase, you want to determine what does the customer define as the problem. Okay, so in the define phase, you want to answer three main questions. You want to answer what is the problem, what is the critical to quality. That means what does the customer expect from you? Okay, so when you look at any Six Sigma project that has been correctly done, what do you see? You need to understand and to know the features and the characteristics, what makes a good definition of a problem, and what has been done at Nike, at Microsoft, at Amazon, at eBay, and so on, with all those case studies that I've shown you. What has been done at KFC, at Starbucks, and so on. These are organizations who have been using Six Sigma for more than 20 years. Okay, so definitely they are doing something right. And if you look at all those Six Sigma projects in all those different enterprises, what is common in all of them? So we are going to use that basically as a background for you to know what needs to be done. So right here, in the defined phase, the first thing that has to be done there is to identify, okay, is it a product, is it a process, or is it a service that is in need of improvement? Okay, that is the first thing. What exactly is it? Is it a product? Are you making shoes, and your shoes, basically the customers, they are complaining about your shoes that they break down easily? Is it a process, or is it a service that is in need of improvement? Okay. Number two, you should actually identify who exactly is driving this need for improvement and what are their expectations. When you identify if it is a product that is in need of improvement, you identify two types of customers. The internal customers, these are the employees responsible or who are involved in delivering that product, okay? And then the external customers, of course, these are the people whom you are getting the product or the service for. And then what exactly they expect from that product, your customers, okay, the people you give your product and the service to, what exactly they expect from you, what are their needs and expectations. So at this point, as I said, I'm showing you the features and the characteristics of a good Six Sigma defined stage, so that when I'm going to show you how to do it, you're always going to have a benchmark that you know that, okay, this is what I need to do. All right. And then after that, now you go to the second part of defining the problem. After identifying a product that is in need of improvement or a service, you identify who is driving the need for improvement and what are the expectations. And then you should now identify, okay, what is required to solve this problem. That means you should have a team charter explaining to the organization, to the process owners, like, okay, this is what is currently wrong. So a problem statement is going to explicitly state what is really wrong with the product, process, or the service, and what do you want to do? What do you want to improve? What are going to be the financial benefits, and what part of the process, the product, or the service that is going to be done, the scope, and what do you need to do to have those improvements? What are the required resources to meet the needs and the expectations of the internal and external customers? And then you also have to outline the areas of risk. That means outlining areas of risk. You are now zeroing in, okay, on the product or the service selection process where most likely things are going to go wrong. And here you're going to use what you call an SLPC chart. And then after that, now you need an approval and sign off from the project champion or the process owner that indeed there is a legitimate problem here. There is a legitimate need for improvement. The cost and benefit analysis makes sense. So this is now what you need to know when you are using this technique. You know, these things, they are more of like when you look at the whole of it, like the Six Sigma project and so on, if you want to use this technique, okay, it is just how can I say this? It's basically common sense for you to know beforehand, okay, what do I need to do, right? Because you're about to do something. So you should actually know before you do anything, not only in Six Sigma or even in life or whatever that you do, you should actually know what do I need to do, right? Before you drive a car, you know that before you start a car and so on and so on, you know the journey, you know how to operate the vehicle, right? So that is the same thing that is happening here. What you're looking at on the PowerPoint presentation, this is what you need to do in the define phase. And this is your first step of identifying and addressing inefficiencies in a process. Now, this is what to do. And then now here is how to do it. Now, how to do it now, again, it gets simpler and simpler right here because at this stage now, you are now going to use the toolkit. The toolkit, a tool, it's a device, it makes work easier. So how exactly am I going to achieve all of this? Well, you are going to use these tools at your disposal. So in order for you to identify a product that is in need of improvement, identify the customer team charter, outlining areas of risk, have an approval, you need to do four things. Number one, you determine the project critical to quality. Project why? That means what exactly do the customers need from your product, your process or service? What really matters most to the customers? Is it the color? Is it time to deliver? Is it the smell? Is it the texture? What exactly do your clients or your customers expect from your product, process, or service? That is the CTQ, critical to quality. And the tools at your disposal, that is your voice of customer, VOC. So I'm going to show you how these tools can be used in the next slide. And then number two, outline business case, okay? At this point now, you are now having your team charter, right? Remember, a team charter with a problem statement, goal, financial benefits and scope and required resources. So you are going to use a business for block and project milestone. Those are the tools at your disposal. So this slide that you're looking at right now, this line is basically showing you which tools to use and so that you can achieve what, okay? This is the how to do it part. This is going to be followed up with the what? With the case study on how this was done. So this is what you do at the first stage of identifying and addressing inefficiencies in a process. And then the third thing, you do process mapping. Why are you process mapping? Because you want to define the project boundaries. And the tools at your disposal is the SLPC or project synchronization. And of course, you have to create a shared vision, again, consult from key stakeholders, that is change management, and you do stakeholder analysis. Okay, so this is basically how to do it. So at this point now, you know what to do, okay, and then how to do it, the tools at your disposal. Now, what you need to know now is how it was done. So these tools, you can these tools now, they are over here in this toolkit. Okay, so this is the toolkit that is going to come alongside your course bundle. Let me just share it with you so that you can see the preview. Okay, so this is the toolkit. This toolkit now that I've shared with you, this is when you're going to get all of these tools and these case studies from 15 different industries. This is also what you're going to get so that you can see how other industries, how Six Sigma has been used in other industries like that. So this is basically now what you do. And remember, ladies and gentlemen, never forget, we are here to identify and address inefficiencies in a process. That is what we are doing. Everything that we do, everything that we are recording, and everything that we're doing right now, we have got one goal in mind, which is to identify and address these inefficiencies. And the first thing that we're doing is basically to what is to define. The first thing that we do, we are defining the problem. In defining the problem, this is what it means. And this is basically how to do it. So let us see how it was actually done. Okay, so this is also a case study that you're going to see, one of the 15 case studies, and this case study is coming from a bank. So just to give you an overview, Six Sigma is a method that provides organizations tools to improve the capability of their business processes. That is Six Sigma. We are improving capability of business processes. How do you improve capability of a process? You improve capability of a process by identifying and addressing inefficiencies. Okay, what does it mean to improve capability? Capability is basically reduction in defects. So that is exactly what you're doing here. So this is going to increase performance and decrease process variations, which is going to lead to reduction in defects and basically improvements in profits, quality of your products and services. So here now, let us look at how this organization basically use these tools to define the problem. So right here, you can see that a quality team at a commercial lending bank, okay, is approached by the sales director. He's very concerned about meeting his sales numbers this year. The people on his sales team have been telling him that they are losing deals to competitors because of customer satisfaction issues. They cannot meet the customer's expectations in terms of delivering funds on time. So consequently now, the customers, they are getting their loans from other banks. So the sales director wants to know how the company can use Lean Six Sigma to decrease response time to the customer. So what is happening here? This is at a bank, right? And at this bank now, they are having a problem that they cannot give out credit card and loans on time. And definitely the customers, they are losing customers because they are getting their loans from other banks. And before we go anywhere, you can see already the similarities as I was telling you. Here we have got a Starbucks location, okay, which cannot process payments on time. And consequently, at this Starbucks or this coffee shop, the customers, they are leaving and they are going to other shops, okay? And that is literally almost the same thing that is happening here. So at the end of the day, this is a process, and the process at this bank, basically, it's having defects. What are the defects that we have here? The defects in this case, basically, is the delay in delivering credit card and loans on time. So we are going to see how Lean Six Sigma can be used to identify and address that inefficient in issuing credit card and loans at that bank. So we are going to start off with the define phase, okay? And in the define phase, what did we say? We said we need to use the VOC, voice of customer, to define the critical to quality. So what is the problem here? The sales director wants to know, how can we use Lean Six Sigma to decrease response time to the customer? How can we identify and address the inefficiencies in the process of responding to customers? Who is the customer here? While the internal customer of this project is the sales director, the ultimate customer for whom the process to improve is the individual or business requesting the loan. Okay, what is the project critical to quality? Based on the voice of customer collected by the sales director, loan applicants, they want faster response from the bank. Okay, so that is basically what you use. That is the VOC. We have defined what is the critical to quality. Okay, so this is now what you have here. What is the project critical to quality? Number two, you now have to outline the business case. Okay, so here you go. Based on the data collection and the interviews with key executives on the Lean Six Sigma team, has developed the preliminary business case as shown below. So this is basically the project 4-block project milestone. And as you can see, what is the vision? We want to have 100% delivery of loan documents to customers on the expected date. What is the problem statement? What is currently wrong with the process, okay, of issuing credit card and loans? So currently 40% of loans are being delivered after the customer's requested date, and this has resulted in $35 million what? Revenue loss. What are the objectives? What do you want to achieve? We want to reduce variation by 50%, and also this is going to save us 28 million. And at this point now, you should not be confused because this is a bank and we are talking of credit card and loans. As I said, if you'd like to have success in Six Sigma, to use this methodology in any point, in any context, you should understand the basics. And that is what I'm showing you here. And from these basics, now you're going to see that from this case study from the bank, you can do it in anywhere as long as there is a need to identify and address those inefficiencies. So that is basically what I'm doing right now, showing you the tools to deploy and at what time. The third thing is basically, the third step is process mapping, project boundaries. The tool at your disposal is the SLPC, okay? So what is happening right here? Using the SLPC tool, the Six Sigma team was able to better define the project boundaries as shown below. So what are they doing right here? At this point now, they are now outlining areas of risk, the project boundaries. So who exactly is the customer here? The customer is the prospective borrower who needs a credit card or a business that needs a loan. What is the output? The output in this process is a completed credit card or loan offer. What is the process of actually doing that? Step 1, step 2, step 3, and step 4. What is the input into this process? Is a credit card or loan application form. Who is the supplier? The new or existing client, the sales representative, the worker in the bank, and the broker who's going to provide the funds. So this is exactly how you define a problem, as simple as you'd like it. And you can literally take this same template that you see right here. You can go to this case study from Nike, okay? And then if you go to this case study from Nike, if you go to the define phase, you are going to see that it is literally the same. And when you go to that case study at Nike, you are also going to see that all of these things here have been done. As you can see, we have identified here, it is the process that is in need of improvement. We identify the customers, what they expect. We have our team charter, SLPC, we are applying the areas of risk. So basically, that is what you do. At this point, you are now addressing the fundamentals. So this is now what you need to, what is required to be done, how to do it, okay? And then this is an example of how it was done. And even if you go again to this case study for define, you're also going to see that is also going to be the same. If you don't have access to these case studies yet, please just make sure that you can also process your payment right now, and then you are going to receive these case studies right away. Okay, if you'd like to follow through with these case studies and basically to get a copy of of all this material, you can just process your payment, and then our team, they're going to add in you right away. Or just check your email inbox and our team, they will do everything. So at this point now, we now need to go to yourself now in the define phase checklist. Now you'll be like, okay, now I understand that Six Sigma is a technique that I use to identify and address inefficiencies. So how do I get started? So you have to start by defining the problem. So what do you need to do? Okay, the first thing you have to do now is to define the customer, internal or external. In the case study, the internal customer is the sales manager, the bank manager. The external customer is the person who is requesting a credit card or a loan, okay? And then in your organization, you have to outline the customer's critical to quality parameter. What exactly do the customers expect from your product, process, or service? And in the case study right here, the customers, they expected what? Faster delivery or faster response on their application, okay? And then you have to develop a business case to determine the problem, the goal statement milestones, and also the financial benefits. So the problem statement here, 40% of credit card and loans, they are basically being replied on a later date. The goal is to reduce variation by 60%. That is from the case that I've read to you. The financial benefits, that was the $35 million, and so on, like that. Okay, so that is all what you need to do. This is now a checklist that I'm giving you, like, okay, how can I get started from this point? What do I need to do in the define first? And then you also have to define a high level as a state of business process. And that is when you use the SLPC chart. As you saw, I use an SLPC chart starting from the customer and then coming back onwards so that you outline the areas of risk. And then you gain consensus by submitting your business case so that you can mobilize the required resources. So here now, as I was telling you, this is your checklist, okay? And then for you, you know that you already know the examples, right? Define high level as a state of business process. You have seen it being done, and this is what it looks like, okay? You have to develop a business case and also to determine the problem goal statement. You already have an example. This is what it looks like. So it's going to be easier for you, okay? Outline the customer's critical to quality parameter. This is now what you need to do here. And there's also another example for you right here. And there are 15 more examples of the same thing being done. Okay. So for you, you are now in a position, okay, to not only know what it looks like, but you also know what are the tools to use. So you come over here to your Six Sigma Black Belt, to your Six Sigma Toolkit, and then you go to the Voice of Customer collection tools, and your project charter. These are the three tools that you're going to use in the define phase. And you also know at the end of it, what does it look like if it is done correctly? And you also know, why am I doing it? Okay. This is also the first step in identifying and addressing these inefficiencies in a process. So that is what it means to define the problem. After the problem has been defined now, what do we need to do? Okay, so we now go to the second stage of identifying and addressing these inefficiencies in a process. So the second stage now is to now quantify the problem. Okay, what does it mean to quantify the problem after we have defined the problem? Okay, so to quantify the problem, that is now measuring. So this is now the second stage. And as I always say, when you go to a certain stage, okay, especially in Six Sigma, it's very, very important that you know explicitly, what do I need to do? How many things do I need to do? Okay, and what does it look like if it is done correctly? So this is now your second stage of identifying and addressing inefficiencies in a process. So at this point now, the end goal is to develop a deep understanding of what your customer wants from you. Okay, you have defined the problem. Now you need to answer the questions: can I measure it? And how is my process performing? So here now in the measurement phase, now you are now addressing this question. Okay, what characteristics the current what characterizes the current problem? This is what you're going to answer in the measurement phase. In the define phase, you answered this question: what does the customer define as the problem? And then right here, you are now going to answer the question: what are the characteristics of that problem? What are the features of that problem? Okay, and that means that is a deep understanding of what your customer wants from you. So at this point, you want to determine, can I measure it so that I know how my process is performing? Process performance, those are the defects and so on. So what you need to do at the measurement phase, and remember, what you are looking at right now, this is what you're going to see in all of those 15 best case studies from 15 different industries. You're going to see that they drill down on critical to quality parameters, okay? These critical to quality parameters, basically, these are now the stages or the steps involved within the project. Why? Within the process or the product or the service that is in need of improvement. Because you said, okay, what is in need of improvement here is this process. So what are the stages or what are the steps that are involved in that process? If you say it's a product that, where the customer's critical quality, what they need most, what are the features and what are the steps involved in meeting that customer critical quality? If your customers say we want faster deliveries, you now have to look at the stages that are involved or the steps that are taken in order to meet what your customer needs. Okay, and then you should now have a performance standard for the process. Okay, so that you can determine its performance measurement standard. So the performance standard, you are going to have a target, a critical upper specification limit and a lower specification limit. Okay, and also you are going to define a defect. This performance standard is going to be used basically so that we know how the process is performing. And your critical qualities, you now need a detailed process map so that you can really zero in and identify what are the stages, at what stages, okay, are those characteristics happening, okay, like what is historically causing issues in that process. So this detailed process map is going to be a closed functional map, basically showing not only the steps, but also who is involved within the process, who is doing what. And then most importantly, you have to define a defect, okay? You have to define what is considered a defect. A defect basically is what makes the customer unhappy. A defect is a mistake. So in that process in question, in that service in question, in that product in question, what exactly is considered a mistake? So that is part of developing a deep understanding of what your customer wants from you. And then you should initiate the data gathering process. So you are going to gather data on the inputs and the output of your critical quality parameters so that you can determine the performance of the process. Okay. When you determine performance of the process, that is going to help you determine the Z score, and basically for you to zero in on the problem, what exactly is required for you to improve. So basically, this is what happens in the measurement phase. Now, in the measurement phase now, this is what it will look like if it is done correctly. This is what you need to do. And then this is now how to do it. So in the measurement phase, for you to develop a deep understanding of what your customer wants from you, and basically to have all of those things that you're seeing, you have to do four things. Number one, you have to define the critical to quality characteristics. So at this point now, you are now going to link what the customer wants to a step within the product or within your service product realization process. So you're going to link the critical to quality, customer's critical to quality, to a measurable process or service characteristic. So in other words, you're going to link what exactly the customer wants from you to a certain stage within the process or within your customer journey. And the tools at your disposal is an X functional process map, a product cycle time, fishbone, and you can use a fault mode and defect analysis. So when it comes to these tools now, in these case studies, I'm showing you the easiest tools to use. Okay, basically all of them, all of those tools, they're going to give you the same result. Okay, so it just depends on which tool do you understand better. So, but of course, as a default in these webinars, I'm just using the tools that are going to give you the results with the least amount of effort, which are basically considered by general consensus is easier to use. Okay, so in this case, to define your critical quality characteristics, I'm going to use an X functional process map that is easier to understand. And then also, you have to outline the performance standard. That means you should give us what is considered a mistake in that process, product, or service, and also what is the upper specification limit and the lower specification limit. Upper specification limit, that means the maximum point before it becomes a defect, and then the lower specification limit, what is the lowest point before it becomes a defect. And then you should now start collecting data. You develop a data collection plan so that you can look for those number of defects on the different stages or the different steps in your customer journey or the product or service realization. And of course, you should measure and validate the measurement system so that you have got reliable and accurate data. So after that now, let us now go over here and then we look at how actually that was done. So this is now the define phase. Let us look at the measurement phase. So the measurement phase now, okay, so the first step is to define the critical to quality characteristics, okay? So that is step number 5, which we have here. So with the approval from the Lean Six Sigma Steering Committee, the team can now proceed to the measurement phase. So it means that indeed this is a big enough problem and it is a legitimate issue that they need to improve, okay? So a detailed process map is created to ensure that everyone has a common understanding of the flow, key inputs and deliverables, and the segment of the map is shown below. So this map now, this is an example of the X functional process map. At this point, we want to link the customer critical to quality to a service. So what is happening here? This is now the total flow within that process that is in need of improvement. So that process now that is in need of improvement, it starts off with a customer in this case, okay? The customer, he contacts the sales representative from the bank. the sales rep from the bank, he reviews the application form, and then he submits it to the credit department. The credit department, they do their credit check and data application, data entry, and they send the information to the central bank. The central bank approves, okay, and the credit department, they send the credit card application or loan application to the operations department, and they prepare an offer, and they return 3 copies, one to the customer, one to the credit department, and one stays with the operations department. So this is still part of defining the critical to quality characteristics, okay? The steps involved in meeting customers' needs and expectations. So this map now helps the team to identify the process steps that have historically caused issues in this process and in approving loan applications. So this is basically the step that has historically caused issues. This step in the credit department, whereby there is credit check and data application entry. So that now becomes our critical to quality that we have linked to a measurable process. The critical to quality, ladies and gentlemen, is that the clients, they need faster response, and the steps or the stage that is responsible for delaying or causing issues in meeting the customer critical to quality or faster response is the credit check and application data entry. How did they know it? How did they define that critical to quality? Well, using a fishbone diagram, the team began discussing the possible root causes of the issues that are leading to unacceptable response time. So, and then they focused, now this is what they did. They said, okay, application approval time. Okay, so here now, we are now using this fishbone diagram that you see here. So they use the fishbone diagram to look at, okay, what exactly is causing issues right here in this process? And then they say there's environment, customer, people, material, and method. And here it was in the method, and that was manual data entry. So as you can see, there's a dotted line on manual data entry here, and that is the dotted line that you see over here. So that is now how you link the critical to quality to a measurable process, okay? And then after that, what do you need to do? We now need to determine the performance standards. So we outline the performance standard. So the team has to determine the best way to measure the problem and also agree on the definition of a defect. So the definition of a defect now, you say upper specification limit, that means the maximum time before it becomes a defect, the maximum time someone can wait before moving on to another bank is 3 days. The lower specification limit, that is the minimum time the bank needs to process the credit card or loan, is 12 hours. What is a defect? A mistake then is basically a credit card or loan that is delivered after 3 days or before 12 hours. So the target, this is now what time the target we need to meet in order to avoid a defect is to process this credit card and loan in 36 hours. Okay, so that is what you have here. And then after that, now you should start your data collection plan. So when you are doing your data collection plan, what are you doing now? You are basically, you come over here and then you go to the critical quality characteristic, to the step that is historically causing issues, and then you start your data collection. So in this case now, the data collection, they focus on time. They looked at the time when the application was received and also the time when this application was released to the credit bureau. Okay, that is how you do your data collection. Even if you want to do data collection here, you come to this point, you measure right here the total payments and also what are the payments that were declined. You go to this stage where the issues are happening. So that is what they did here. And then in their data collection, as you can see, they said the timestamps, some files they took 10 minutes, some files were rejected, some files they took 5, some 1, some 3. So this is now the variation. And ladies and gentlemen, that is what we talk about when we say a deep understanding of what your customer wants from you. This is an example of translating the voice of the customer to become the voice of the process. The voice of the customer said, okay, they want faster response from the lending company. But however, the process now, this is what is responsible for faster response. If we solve this problem in the process, this variation, we have solved this section here. So it is called a deep understanding of what your customer wants from you, because the customer wants faster response, but faster response can be done by reducing this variation, because if this application is rejected, it means more time and so on. So that is exactly what we are doing here. So this is now the measurement phase. now, how do you get started and how can you do it in your own organization? So in your own organization now, you are now going to start off with this checklist, okay? So the first thing is to link the customer critical to quality to a need or a service or process. So at this point now, you use the X-functional process map, you lay out the key inputs, your cross-functional map, all the stages involved in the process, okay? And then you determine what is the step that is historically causing issues in your stages, the same way that you saw how they did it in data entry using the fishbone diagram. And then you ensure that your operational definition is the same as the customers. So that means your operational definition, critical to quality, is the same as the customers. And right here, because there should not be any difference between what time exactly do you expect between your organization and the other ones. And then you now outline the performance standard. What is a defect? And then in this case, a defect was a credit card being issued after 3 days, or if you want to process it under 12 hours. The target, in order to avoid a defect, that is 36 hours, and the upper and the lower specification limit, that is basically the maximum point before it becomes a defect, and the lowest point it becomes a defect. So as you can see, everything that you see on the checklist, there is literally an example in the case study, and that is basically how you do it, because if you familiarize what is in the case study and what you see here, that is going to be easier for you. And then you develop a data collection plan. That means you're now going to go back to the first step, okay? This first step right here, when you link this critical to quality to a need or product or service, that is when you are going to look at the inputs and the output of that critical quality characteristic, and then you're going to do your data collection. Just like in the case studies, they did a data collection on the inputs and then the outputs so that they could determine the number, when these files have the performance of the process. And then you should ensure that a reliable measurement system is in place. And in this case here, we have a reliable measurement system because we have a reliable measurement system because this is computer entry, so that is reliable. So that now completes the what? That completes the second stage of identifying and addressing inefficiencies in a process. We have defined the problem, we have quantified the problem. We have what? Determined what does the customer define as the problem and what are the characteristics of that problem. So we are now going to go to answer this question, what are the root causes? What are the root causes? That means we have to analyze. We have to identify the cause of the problem. And at this point now, it's very important for you to know that the problem is somewhat changed here. So as to say, because the problem, okay, it started as this. This was the problem. We need faster response from the bank. But now, this is our problem right here. Okay, our problem now, we translated the voice of the customer in the measurement phase. We translated the voice of the customer, okay, to become the voice of the process. So as you can see, the voice of the process here is telling us that some files are being rejected, some are going through, and some are being delayed at this stage right here. So that is now what you are going to analyze. In the analyze phase, we need to identify the cause of the problem. In the analyze phase, we need to identify the cause of basically these numbers. Why is there variation? In the analyze phase, we want to identify the cause of these points 1, 2, 3. Okay, because in the measurement phase, yes, we know that there is a problem in the payment, and then these are the characteristics of the problem. But now in the analyze phase, we want to see what is causing these items that have been listed right here. So, as I was saying, this is just like, don't let it confuse you, because here we have got numbers, and here, okay, and here we have got sentences, and then all of a sudden it's a new concept. This is literally the same thing. At this point, the characteristics of the problem happens when the application is opened, application logs out, the application is slow, okay? And here, basically some files are being rejected and some files are going through. This is literally the same thing, okay? So please don't let this confuse you. It is literally the same thing. Because as I've mentioned to you, in Six Sigma, usually the problem is that other people, they can only use Six Sigma in one scenario, in one process. You can find out that someone can use Six Sigma in food service, but has got no idea whatsoever in e-commerce, okay? And that is not a good way to do it, because whenever the process changes, you are going to learn Six Sigma all over again. So the smart thing to do is for you to understand the concepts. What at a fundamental level, what is happening? Okay, if you really understand what is really happening at a fundamental level, you are always going to have a guide. For example, right now, we are in the analyze phase. You know that at the basic, at the foundation, this is what needs to be done. Whether you are doing Six Sigma for space shuttle, for aircraft, for a lemonade stand, for the president, for the whole country, whatever that you're doing in 1 million workers, 3 workers, 5 workers, any industry, you know that at the end of the day, this is where I'm going. That is going to avoid the situation whereby you have to learn Six Sigma every time. So in this case, it means that, if you don't grasp the fundamentals, you have to learn it 15 times so that you can use it all over here. Or isn't it better for you just to learn the fundamentals as we are doing right now so that you can apply it at any point? So that is exactly what I'd like you to know. Everything here, what happened at this Starbucks location, it's literally the same thing that happened in this case study right here. So we have got a case study from eBay. Where is it? We have a case study here from eBay. Let me try to open it up. This should be in e-commerce, right? Right here. So we have got this case study in eBay. This is about $3.5 billion problem, okay, here. And if you open this case study for $3.5 billion, there is literally no any difference with what has happened here. If you look at a fundamental level, literally, you can do a comparison side by side, and it's the same thing. And for this $3.5 billion is the same thing that you're going to see in this rubber manufacturing company. And it's the same thing that you're going to see at the Starbucks location. And it's again the same thing that you're going to see right here. Okay, so it's all about really understanding what it needs to be done. So right now, we are now at the third stage of identifying and addressing inefficiencies in a process, and we are now identifying the cause of the problem. At this point now, we would like to know what are the root causes. What exactly is responsible for these characteristics of the problems that we have identified here? So in the analyze phase now, okay, you want to start exploring all the possible root causes that can affect performance of your process and or your product. What exactly is the root cause here? At this point, you want to determine two main things. What is your current process performance and what are the root causes? What is your sigma level and why exactly are you at that sigma level? Okay, so in analyze phase now, you have to do three things. Number one is to determine what you call baseline process capability. That means how good is your process? How good is your product? How good is your service? Okay. And then how good do you want your product to be? How good do you want your process to be? How good do you want your service to be? And what is the reason why your product or your service or your process is not as good as you want it to be? You understand? Very simple. That is how you identify the root causes. Again, I'm going to repeat. What you do here, okay, because in the define phase, you define the problem, okay, and then you saw in the define phase, you saw what the customer defined as the problem. In the measurement phase, you basically looked at the characteristics of those problems, okay, the features and the characteristics of the problem. Now, you want to know what exactly is the root cause of those problems. Okay, what is the root cause of those characteristics? Why is it happening? So you first of all have to measure how good the current process is, and then how good do you want it to be? So you can determine how good it is. Maybe it's sigma level 1, and then you want it to be 6 sigma level, and then you list down the reasons why is it not 6 sigma 6. It is basically at sigma level 1. That is all what you do, and that is how you determine what is my current process and what are the root causes. So this is now what needs to be done, and this is how you do it. The tools, as you're going to see when you get your toolkit, this is really going to help you a lot, because once you have your toolkit now, there is no any Six Sigma project that is too big or complicated for you, because everything you are going to be using those toolkits from your toolkit that you're going to get on your student dashboard. And right here, for baseline process capability, how good is your current process? You should have graphical representation of capability. And that means you are going to determine your current sigma level. You compare your process performance with what your customer expects, with your target, with your upper specification limit, and with your defect. And you are going to plot it on a histogram. Okay, so use a histogram, run chatbot plot, or Pareto analysis. Second thing is to define the performance objectives. How good do you want that process to be? What are the goals that you would like to have? What is the capability? How many defects would you like to reduce? So you benchmark by comparing with other people who are doing it correctly, which is literally the same thing that we are doing in this webinar. This webinar is literally just the benchmark, this presentation. Okay, we looked at good examples of Six Sigma, and basically we are taking you from wherever you are to meet the best practice, which is basically benchmark what other people are doing. That is what the case studies are for. And then you now identify the source of variation. The source of variation, it's literally the difference between the process capability and also the objectives that you want to achieve. That is basically the source of variation. So those are called the list of X's. X's basically, these are the factors that are affecting the process, your capability. What is responsible for you not meeting your attainable goals? And the tools at your disposal here, you've got value add, non-value add, SOE, tag time, and effective hours. So let us now look at these tools, how they were used. So this is now the analyze phase. And remember, in the analysis phase, we want to determine the root cause of these characteristics. So we're now going to start off with the baseline process current capability. In other words, how good is this process? So the team members, the members of the project team, they calculated the process capability to ensure that they properly documented the current performance level before any improvements were implemented. And using data for the previous year, they calculated the difference, okay? So we want now to see how good is this process of issuing credit card and loans, right? That is the first thing that you do in analyzing like that. So we calculate the difference when a credit card application was received and the time when we communicated to the borrower. So using a statistical software or Excel or the link for Minitab in your file in your toolkit, they calculated the values for the average and standard deviation. So since they knew that the customer expects the answer within 3 days, a Z-score was calculated. So this is now the equation for the formula for the equation for the Z-score, the sigma level. So you say upper specification limit, okay, minus the average, which was calculated using Excel, divided by standard deviation, again, which was calculated using Excel. And then here now you get 0.3. So the sigma value Z-score of this process is 0.3, which is less than 1. This is a poorly performing process. So this is currently how good this process is. But we now need to present it graphically. So what does that mean? It means that, we are going to compare 0.3 capability, okay? So we are now back here, all right? You see, this is now 0.3. So that means we have at least 900,000 defects per million opportunities. So that means if this process right here, this process of issuing these credit card and loans, for every million customers, 900,000, they are not getting the response on time. So what you're going to do now, we are going to compare the current performance. We are going to compare the sigma level of 0.3 with the customer expectation, okay, and also the performance level required like that. So as you can see now, this is what it means. So graphical representation, it also shows you in this case like how bad it is, because if you just represent it as a number like 0.3, but 0.3, how far off are you from the target? So as you can see, this is the frequency of issuing credit card and loans, 10, 20, 30, 40 loans being issued. And basically, you can see the target here is 36 hours. So you can see the majority of all these responses, they are being done after like that, okay? The upper specification limit and so on. And 30, 60, 90, 120, these are hours that are passing by. So this is basically what you call the graphical representation of capability, okay? So after that now, what do we need to do? We need to develop attainable goals. Okay, now how good do you want it to be? So the first one, the process is 0.3. Okay, it's making 900,000 mistakes per million opportunities. How good do you want it to be? So for this project, since the customer requirements were clearly defined, benchmarking to refine the project goal is not required. So the team, we are going to move to step number 11. Okay, step number 11, because we already know what you want to achieve. We need what you want to achieve here. What you need to do, we need to reduce variation, what he said here. We need to reduce variation by 50% within 6 months. So this is the goal that we are going to use right here. Okay, so definitely at this point, we are delivering only 10% of these credit card and loans on time. We want to move from 10% to 50%. So what is the thing now? We now need to look at the source of variation. Our process capability is 900,000 mistakes per 1 million opportunities. Okay, our process capability is 10% satisfaction rate. Our performance objective is 50%. So what are the sources of variation? What are the reasons responsible? Why are we getting 10% instead of 50%? So that is what we have here. Those are the sources of variation. So what we do here, we are going to give out as many reasons as possible. Some people, they can suggest is the name of the bank, is the people who are working, is the color of our forms, whatever reason, okay, whatever reason that you think that can be the reason, okay, why with these two they don't match, why our why our capability does not meet our objectives. You can do any reasons what you want, okay, but all what you have to do for whatever reason or whatever explanation that you come up with, you have to confirm if there's a relationship to the lost deals. So one of the reasons this team came up with why exactly they cannot meet their performance objective, they said, is because of response time. They said we are losing deals here because we are taking too long to respond to the customer. One or probably 40 or 30 reasons. Okay, so for every reason that is given, you have to compare, okay, is there a relationship to what you are trying to improve? Because here you want to reduce the number of the deals you are losing. Or maybe here some they said we are losing deals because of the color of our forms, the name of our bank, the logo, our office location, whatever they've said. But here now, the final one was response time. So you compare, there should be a relationship. So you conduct a correlation study and you also plot using the scatter plot. So what they did here, using 2 quarters, data from 2 quarters, they plotted the average response time for each month and the number of lost deals. And using a statistical software, the correlation coefficient R was calculated to be 0.979. So this is close to 1. It means, yes, indeed, from the 40 reasons that you gave us, with this reason, yes, it is legitimate. Okay, there's a strong relationship between this reason of response time and lost deals. So yes, indeed, one of the sources of variation, one of the reasons why this process cannot meet its objective or the performance objective is because of response time. So we conclude that the longer it's taking for us to respond to the customer, the higher the chances that they are choosing another lender. So these were the results of the scatter plot. And as you can see also, these are the lost deals in cycle time. And also all these dots, they are close to this line, which means there's a strong relationship. This is very important because at this point now, we now know the root causes. This is what we did in the at this point. So now that the team understood that there's a relationship between the time it takes and the lost deals, again, we need to verify to determine that, okay, so if we solve this problem, okay, other banks are there which are really, we need to determine if really the other banks, the people who are doing better than us, are they really better at solving this problem? In this case, responding to customers. So what you do after you identify source of variation, first step, you confirm its relationship to your goal, to the goals of the process using a scatter plot, and then you compare to other people, other processes, other banks. So to answer this now, you conduct a hypothesis test. This is the second thing. So the t-test result, as you can see, this is the formula. And then, as you can see here, they said, using the statistical software, the results of the t-test are the cycle time for the company. We are taking 2.7 days. The other banks, they are taking 1.5 days. So the company's competitors, they are responding to the borrowers within 36 hours. having received the information, whereas we are responding to 2.7. So we now confirm that yes, indeed, the other people, the other banks who are performing better than us, they are also good at this problem. They have got what? A good cycle time. So armed with this information, that means we are facing far better performance, and that is what we need to improve. So this is now what you do in the analyze phase. So I'm going to repeat for you. In the analyze phase, the first thing is to determine how good is your process. You calculate your Z-score, and then you compare your Z-score to the customer needs, your target, and also your specification limits. And then you define what do you want to achieve. And then when you get the reason, what is the difference between your objectives and your current capability? First thing, you confirm the relationship on a scatter plot. You do a hypothesis test with other process to see if indeed or if you solve that problem, are you also going to improve like that? So that is what you do in the analyze phase. Now, how do you get started in your organization? In your organization, when you go to the analyze phase, the third step of identifying and improving processes, the first thing is to define and calculate a Z-score. Okay, so as you can see in this bank now, the first thing is to determine how good is the process. So this bank now, they started off by what? By defining and calculating a Z-score, and the Z-score here was 0.3, which is about 900,000 defect parts per million opportunities. And then the second thing, you develop a graphical representation of data to detect patterns. So you compare that Z-score, okay? What does that Z-score mean when it is compared to what your customer requests from you, your target, your upper specification limits, and your defect? Graphical representation on a histogram. And then you now do best-in-class operations to better refine your goal. Now that you've understood how good is your process, you now determine how good do you want it to be. And the best way for you to determine how good you want it to be is to have a benchmark, okay? So you compare with other people, with other processes that are doing better, or the process that you admire. And then you now have to identify a list of potential X's. X's, these are basically the factors that are affecting your process, why you are not having your objective. So you are going to see that for this list of X's, there are going to be many reasons. Probably for that bank, maybe there were 20 possible reasons that came up as potential reasons why they cannot meet best in class or why they cannot meet their operation objectives, why they cannot meet 50% reduction in variation. So for every potential X, that's why it's called a potential, okay, source of variation. The first thing you do, you confirm if indeed that X does it have a relationship, to the goals of the process. You do that with your scatter plot. And then number two, you do also hypothesis test to compare with other institutions. And then you do statistical testing on population differences. That is when you do your t-test result. As you saw from that case study, the t-test results were the bank was taking 2.7 days, while the other banks, they were taking 1.5. So that is basically what we do in the analyze stage. And then after analysis now, we now need to go to the last two stages now, okay? The last two stages of identifying and addressing inefficiencies in a process. At this point, we have answered, okay, we addressed what does the customer define as the problem, what are those characteristics, and what are the root causes, okay? So we now need to look at what controls should be implemented to sustain this improvement. So this is now what you're going to do when we implement and verify the solution and when we maintain the solution. Just to give you a revision, okay? What does the customer define as the problem? The customer defined as a problem, they say, the customers are saying they want faster response from the lending company. The bank is taking too long to get back to the application. What are the characteristics of this problem? This is what we established in the measurement phase. We saw that in the application and data entry stage, some files, they are taking too long. Some files are basically being what? They're basically being rejected, which is resulting in longer time. So what are the root causes really of this problem? What are the root causes really? Why are we now losing deals to other competitors? So we now went to the analyze phase. We determined like, okay, first of all, before we look for root causes, is there the problem? And then we saw, yes, through the Z-score, our current capability is 0.3. What is our objective? We need a higher sigma level. What are the root causes? And then basically that is, yes, indeed, we are taking too long to respond to the customers. We confirm through the scatter plot and also the hypothesis testing. So we now need to know what controls should be implemented to sustain this improvement. What controls should be implemented to address the results of these root causes? What controls do we need to address the root cause of response time? So that is what you're going to do right here in the what? In the improvement phase. So in the improvement phase now, again, what exactly is the key here? Please, we are now about to go to the end of this webinar. I just want you to understand that in Six Sigma, okay, for you to avoid learning and relearning, whenever a new scenario comes up, you have to relearn again. You have to understand the basics. Understand like, okay, at the end of it, what does it boil down to? If you base your knowledge and you understand what does it boils down to, you are going to see that it's going to be easier, not only for you to identify and improve inefficiencies using the DMAIC methodology, but you're also going to do it in any situation. So in the improvement phase, the whole thing here, okay, is to determine how can I fix the root causes from the analyze phase. This phase is focused on selecting improvement ideas that were identified by the team or determined through data analysis. So at this point now, you look at the root causes, okay, the source of variation, the potential list of X's that you established in the analyze phase, and then you focus on improvement ideas. Well, how can I fix those root causes? So at this point now, you are going to screen for those X's and solutions. So those X's which have been confirmed, okay, through hypothesis test and also the scatter plot, and then you now look for solutions. So you literally have got one job to do here. And in order for you to determine how can you fix those root causes, you have to identify the vital axis. Like, okay, what were the main factors that are really affecting this process? Okay, like at this point, you're now going to be, grading or categorizing you are going to be categorizing the axes, okay, the factors that are affecting the process. So that is what you call identifying vital axes and implementable what? Solutions. So what are the deliverables here? This can result in workflow redesign, okay? These are all things or, what you do to fix the root causes. So they can be standardization, okay, or they can be quality and optimization. So the tools at your disposal, you are going to use lean tools if the sigma level, okay, is less than 1. If the sigma level is more than 3, that is basically regression in the sigma tools that you're going to use. So this is now how you improve. So when it comes to improvement now, this is when you identify the vital axes and implementable solutions. This is how you determine how can I fix these root causes. So what you do here now, you first of all go back to the measurement phase to pick up that critical to quality characteristic where you link the customer critical to quality to a measurable process. And in that measurement phase, in this case, the team agreed that manual data entry process had the largest impact on the overall cycle time. Okay, so manual data entry cycle time, this is the one that had the largest impact. Okay, this is the one that is impacting what? Cycle time. Why do we need this one right here? This is actually affecting the time it takes to issue the credit card and loans, which is also the root cause that we identified here. The root cause here, the source of variation, is response time. Okay, so at this point now, we need to understand why. Why is it data entry cycle time is basically responsible for overall process cycle time? In the improvement phase, that is what we determined. But now, in the improvement phase, we need to determine why. So we are going to use the same tool, which is the fishbone, to conduct another brainstorming session. And all what you're doing here, we are looking for ideas, okay, on how can we fix those root causes. And in this case, we are looking for ideas on how can we fix the root cause of late response. So the results pointed out one central reason, which is missing critical information. So they use the fishbone diagram like this. So they basically said, okay, this is now the data entry, okay, application data entry, okay. So they use the fishbone diagram to determine what exactly is affecting that step. So they said it can be customer, people, environment, and missing information. So missing information here is the reason, okay, why we have this variation here, okay? Missing information is the reason why this is a step that is historically causing issues in approving loans. Missing information during credit check and application data entry is why some files are being rejected and some are being delayed. So what exactly are the features? Because we say it here, you have to identify these vital axes, okay, like the features and the characteristic. So here now you can see that missing information can be caused by three things: the method by which the information was received, whether a list of required documents was provided during application, and the varying types of documentation requested by the operations team. So as you can see, this is, of course, these days, no one is using fax anymore. And also, you know that right now you are given a checklist when you do the application to the bank, because this was, it was a case study, okay, by Citibank. This is actually an actual case study for Citibank. I think it was in 92 or something like that. Okay, this is actually when they were using it like that. So it's an actual case study which they were using. It's a little bit outdated in the context of like there's no fax anymore, and of course all banks, they are now using checklists. But this is actually a case study for Citibank in their North American operations. This is what they were doing. Okay, so it also just shows you that, Six Sigma, even though it has been done so long, still the concept is still the same, because all what you need to know is that when I'm using Six Sigma, all what I'm here for is to identify and address inefficiencies. It really does not matter on any context or whatever. So here now, this is now what they did. So the team, after this brainstorming session, they said these are the three things that are affecting missing information. But we need to validate the theory. Okay, so we are going to use regression to determine the mathematical relationship between missing information and process cycle time. And sure enough, with the high adjusted R2 value of close to 90%, there is indeed a strong relationship between missing data and cycle time. So documentation cycle time, the time it takes to give out the credit card or loan, and then this is the regression equation. And you can see if there's a missing data of 3.2, it results in documentation delay time. So now the team has to determine what elements of the in the process of customer data collection they need to change in order to never exceed 3 missing data points. Because if you exceed missing data points, 3 missing data points, it is going to result in the delay right here. And indeed, that's why this step is causing historical issues. And that is what you want to do here, isn't it? We want to select improvement ideas. Okay, so what improvement ideas can we have to keep this missing data point to not exceed 3 missing data points on credit card application? So what we are going to do here now, we are going to do what you call DOE, design of experiment, which is what you're going to see right here at the end in your toolkit. Okay, designed for Six Sigma, etc. on like that. So what they did here now, the team, they said, okay, this is what you're going to do. They are now going to, for this case study, the team knew that the critical drivers for missing data were they need to have improvement ideas on the method by which the information was received, email versus mail, whether or not a list of required items was provided, and whether or not they requested for 1 or 2 years of the bank statements. So the team, they said they set up an experiment in which 1, 2, all these variables were changed and the documentation cycle time was measured. So basically they were changing, okay, these variables, and they measured the time it takes to deliver the credit card or loans or to respond to the customers. So the objective was to test this process under all conditions, and the results were started using statistical software, which is literally Excel, okay? And the team concluded that the process cycle time was significantly reduced when a list of items, when a list of required items was provided to the borrower and she asked to email all the information. So asking for 1 or 2 years of bank statements did not have any impact. So now the team, they must pilot these solutions to confirm the result of the experiment and to deploy control plans. So that means the team here now, they agree that, okay, we are now going to give a checklist to the borrower, and also we ask them to send the application forms by email. This has been the method that is successful in keeping these missing points on a file on 3.2. So that is an example of an improvement idea that has been identified by the team. Okay, so this is going to be piloted. That means for the next 3 or 4 months, they are going to be sending a checklist and also requesting this information, the application forms, to be sent via email. Now, for you now, what do you need to do now? For you now, in the improvement phase, the first thing is to have a short list of your axes. That means you look at all the sources of variation, okay, from the analyze phase, you grade them in level of importance, the ones with the largest impact first, and then like that, okay? So after that short list of axes, you ensure that all your axes, they are really controllable, and you don't have any processes in those lists, in those, you don't have any processes within that source of variation, because you have to look at factors that are affecting the process, not the processes. Okay. So in this case, in the case studies, we saw it was missing information, and we listed down what exactly is responsible for missing information. And then we now have to establish the improvement approach. So the improvement approach here, basically, it was Kaizen. We used the group discussion, a brainstorming session, to identify how can we really solve missing information, okay, on the 3 factors, which is mail, the checklist, and the 2 years of bank statements. And then if you're pursuing a Kaizen event, like what we have done here, okay, in this case study, we need to support and implement, you should have necessary support to implement the improvements, because now the team, they are now going to change the way that credit card and applications are being done at this bank, okay? So of course you need support and basically, approval from the top management in order to change the way you work, and in this case was to do like that. And then also, when after you identify, okay, the your potential axis, you should actually make sure that the R2 value, okay, when you are validating your theory of the factors that are affecting the process, if the R2 value should have an acceptable level of predictability. And here the R2 adjusted value was up to 90%. So yes, it was, we confirmed that relationship. So that is what you do in the improvement phase. So at the improvement phase now, we are now going to go to the last component, which is basically to maintain the solution. We have identified and we have addressed these inefficiencies, okay? Now it is time to maintain the solution. We want to make sure that, these controls are now implemented to sustain the improvement. So for the next 3 months or so, okay, or given that time, we are going to be using this new method, and we are going to test it in the control phase, which is the last one. So here is now the what? This is now the control phase. And as usual, this last phase, and as usual, you know that we need to understand what do I need to do before you actually do it. So what you're trying to do here is, how can I keep those root causes in control so I don't have to fix them again? Okay, how can I keep the root causes of missing information in control so I don't have to fix them again? So this phase focuses on successfully passing the project to a functional owner so that you ensure what? Long-term sustainability. So that means we are going to try the improvement ideas for some time, and if indeed that solves the problem, we are now going to pass on to the process owner like that. So here now, the first thing that you do in the control phase, we need to validate the measurement system analysis on the axis. And in this case, the main X was missing information. So whatever factor or the X that is affecting the process, there should be a measurement system so that you can check if indeed those factors, they are in control. So in this case, we need a measurement system on missing information, so that we can validate if indeed the improvement ideas, they are working. So we should always check if indeed those factors, are they still reoccurring? Are we still having those X's? Are we still having those sorts of variation, or they've been actually reduced due to the improvement ideas in the previous stage? And then after that, if those X's now they're being controlled, we now need to determine the process capability. Now, how good is the process? Okay, at this point, you want to see, is there any improvement? Because in the analyze phase, with our process capability, we measured it, and it did not meet the process, the objectives. So we now need to determine what improvements have been brought about with these improvement ideas. And then after that, now we have to implement process controls. Process controls, that means this is now when we keep these root causes in control, so we don't have to fix them again. So this is what needs to be done, and this is how you do it. So those are the tools at your disposal. So in the control phase, this is where you are trying to keep the root cause in control so you don't have to fix them again. This is the last stage of identifying and addressing inefficiencies in a process. So you validate measurement systems on your axis to make sure that indeed the factors that are affecting performance of the process, they've been controlled, or they are reduced due to the improvement ideas. And then you determine what you call post-improvement capability. How good is the process now after those improvement ideas? And if everything checks out and then you meet your objectives, the goals that you set in this defined phase, this is now when you have to implement process controls so that you can successfully pass it to the project owner. So this is now how these projects are controlled, okay? So in the control phase, as you saw right here, what did we say? The first thing is to validate if indeed these axes are in control, okay, if they've been reduced. So on a daily basis, 40 random files were collected and the number of missing points was counted, okay? Because that is what you're doing, missing data points. That is because all this improvement idea is to reduce this data point, missing data points on the application file. So for 40 days, we are counting, we are validating the measurement system on those axes. And this process was repeated for 20 days, similar to the data collection process. And this data was plotted using a C chart to indicate the average number of missing data points for the 40 files on a daily basis. And sure enough, it was 1.15. So that means, yes, indeed, these axes, they've been controlled. Missing information, we have to keep missing data points on application forms below, what was it? It was below 3.2. And right now, the average was 1.5. So it means these improvement ideas, they were working. But however, if you look at day number 6 here, we had 4 missing data points, okay? But on the other days, from day 1 to day 20, we all had, less than 3 missing data points. So at this point now, we now have to determine what you call post-improvement capability. So post-improvement capability, before these improvement ideas right here, what was the sigma level, okay? So we collected 40 random files before for 20 days, 800 files were the 267 defects. That means for every million opportunities, we had 333,750. And so that is a Z-score to 1.9. After those improvement ideas, after, okay, requesting for when we started receiving applications via email and giving them a checklist, basically we reduced it to what? To 23. So that is the improvement here. So as you can see, the Z-score now here is at 3.4. And then you go back now here, 3.4, that is about 95% or so, okay? And then definitely that is within their range of 50% reduction in capability as the goal that they've said here. So that is now the improvement idea. So at this point now, what is going to happen is basically now the cost and benefit analysis. So the organization is going to determine, okay, satisfaction rate of 95%, is it okay, or they want to increase it again? So if they want to increase it again, what they are going to do, simply they are going to come back here, okay? They are going to come back here on these axes right here, the final and short list of axes, and then they go to the next stage, because here they only solved one X, so they go to the second one, third one, if it exists, and so on until they reach 6 sigma. But usually, you should also consider the cost and benefit analysis here, because the solution should not cost more than the problem. So the team was able to gain substantial improvements. For them, 95%, it is more than enough. It meets their cost and benefit and their objectives. So the good control plan for once process critical axes, the team's final step will be to develop a control chart for the process. So that is basically what you see. So this is now the case study for Six Sigma, and you're going to see that, it's literally the same thing that we have done here and also over here. What I would encourage you to do is basically to just go through as many case studies as possible. So when you're going to receive this case study, this PowerPoint presentation, try to figure out where exactly, how was this done here, okay? You just go to any in healthcare, even if you don't work in healthcare, because that is the way that you're going to be nimble, so as to say, to be flexible, to work in any condition, any process. You do it by basically identifying how it was done. Even let's say it is in distribution, okay? You go right here to this case study in distribution, and then try to identify how exactly was this done in distribution. We are going to know that at the end of the day, you will have got enough examples and you can work it in any way. So to conclude and to wrap up this webinar, in the control phase, you have to validate that the measurement system is adequate for measuring your critical axis, because there should be a way that you're going to know how, whether or not the improvement ideas are working. And the best way to do that is to keep a tab on the axis. And then you should also verify that the process improvement that you tested in the pilot, they've really attained their goals, okay? That means this is post-improvement capabilities. And then you hand off the process to the process owners. It's one of the most important things in Six Sigma to actually know when to wrap up the project after the goals have been done. And then you develop and implement a strategy for control, such as risk management or mistake proofing, like that. So that is basically how you do it in Lean Six Sigma. That is the methodology that is used to identify and to address inefficiencies in a process, okay? So as usual, thank you so much for attending this webinar. For most of you here, you are not new, so I believe all of you know how it works. This webinar is basically a promotional offer, okay? This is the link that if you'd like to see the sample certificate and how it looks like, you click over here. This webinar, it is basically a promotional offer for this package, okay? Usually this package, it goes for $49 per month as a subscription. But today, if you pay $65 before this link is deactivated, you are going to have lifetime access to this course bundle, okay? That means you are going to get the green belt and the black belt training. You are going to get 15 case studies. You are going to get the green and black belt toolkit, plus also your exam certification for revision or to improve yourself, okay, if you'd like to. So that is how it works. But please make sure that understand this is a promotional offer and it ends today. At some point, this link is going to be deactivated, and that means the $65 option is off. To verify the authenticity of your certificate and also to update your CPD program, this is the link that you are going to use, okay? And if you'd like to see how does the sample certificate look like, and also to process your payment using any card in any currency, that is your link right there. So thank you so much, ladies and gentlemen, for taking time. Until next time, I'll see you. Thank you so much. Bye-bye.